GAC, this is Coach Johnson. Some of you are in Algebra 3 right now, and if you have questions, that's what today's podcast is for, is just answering any questions you have off of the MML and off the previous section. This may be pretty quick, depending upon how much is needed, but what I'll end up doing is just kind of going through them. If at any time you have a question, feel free to put it in the form of a picture, okay, because it's dependent upon your MML question there. So just text me that, text me the picture or text me the question, and we'll go through that together. Until that happens, what I'm going to do is I'm just going to go through a rundown of the specific problems, identify specific strategies that I would use to be able to work on each one, and then get it and go from there. So again, if you have questions, throw them out there, and we will rock and roll. So unlike last time, let's hook this up here. Perfect. Hoping this will work. Excellent. So the one that we were going to look at is section 2.3, okay? Section 2.3. So we're going to click on that one. All right, 2.3. And let's just do this. Let's go through question 1, and I think I might have to actually change this up just a hair. So let me see here. I might have to change this up. Perfect. All right, let's do this one. All right, so one of the things that we want to do when we come to any of these problems is to identify whether it's a polynomial or not. Remember, it's all dependent upon the polynomial, that is. It's all dependent upon what the exponent's doing. So as long as the exponent is, number one, it's positive. It's either 0 or greater than 0. And then also it can't be a fraction. So as I look at this, I understand that right here, this right here has the proper, this right here, this problem is a polynomial. So then we look at what is the degree. So we can look at the degree of this by knowing what is the highest exponent. Well, remember, the highest exponent is what our degree is. So in this case, since the highest exponent within this polynomial is to the third, our degree of the polynomial will be 3. Okay. By the way, what would be the lead coefficient in this problem? Well, the lead coefficient would actually be 6, okay, because that's the number in front of the highest exponent. So just again, giving you a heads up there, that's kind of what we're looking at on that number 1, okay? And by the way, I know I already said this. Please make sure, text me if you've got any questions on it. I see a viewer right now. If you've got a question on one, throw it out there and go from there. In fact, I've got a question. So what we'd like to do here is the question will trump that. So what I'd like to do is go to number 10, okay? Excellent. Perfect. All right, so let's do this. Let's go to number 10. Let me go to number 10 here. And we always can come back to other ones if we need to. Let's go to number 10. Perfect. Now, if I need to, I can always come back to it. But what I'm going to end up doing is just kind of explaining this. And then hopefully after that, might be of benefit to then use the pad to kind of show you on hard copy there. All right, it says this: the graph to the right is a complete graph. That is, it is continuous and displays the functions and behavior. All zeros are integers. Answer the following question. Find the zeros and state whether the multiplicity of each zero is even or odd. Well, the big thing to kind of note on this, and this is kind of, this is a little bit tougher. I don't think that anybody would have any, well, right here it says, what is the value of the -0? I don't think anyone would have any questions in telling us that -3, 3, and 5 are the 3 zeros within this expression. In fact, I'm going to do this one just because I think, again, Travis been here. I'm gonna do this with you. This may be the exact one. If not, we'll just take it and go from there. But it should be -3 is the -0, and we're correct, okay? Then it says this: is the multiplicity of this 0 even or odd? Now, I'll be honest, this was not something that we hit on within the previous section. You would really have to watch this podcast in order for this to happen. Now, to kind of answer this question, let's do this. Let me get out of here. And instead, let's go to this right here. Here we go. Now, let's say that we have this graph that goes at -3. I think it's 3 and 5. So it kind of goes like this, goes through 3, and then kind of goes through, should be 5 right there. Something that looks like this. Now, you know that -3, 3, and 5 are the zeros of this polynomial. You know that that's where zeros is the same as x-intercepts and is the same as sometimes if you look at roots, okay? And it's where it crosses the x-axis. That's what that is. But in multiplicity, let's say that I had an equation. By the way, this is unrelated, okay? So on this side, let's say that I had an equation where it said x minus 3 squared, x minus 1, and we set it equal to 0. And I were to tell you what are the x-intercepts of this expression, you would say x equals 3, coach, and x equals 1. And you did that because you set x minus 3 equals 0, as well as x minus 1, sorry about that, put this down here, x minus 1 equals 0, add 1, add 3, and that's how you got the 3 and 1. But there's a little kicker here, something that's a little different, because you see this expression right here, you see that? That right there is actually a multiplicity. What multiplicity means? Multiplicity means how many times are the zeros repeated? How many times are they repeated? So in this case, since this is to the second power, and this kind of just goes below, this 0 of 3 has a multiplicity of 2, meaning there are 2 of them. Whereas with this, since it's only to the power of 1, an understood 1, this has a multiplicity of 1 here. So what happens when you have a multiplicity of 2 versus a multiplicity of 1? Well, we actually have two different kinds. We have odd and we have even. In the case of odd, it goes through the 0. Goes through the 0. Okay? Goes through the 0. In even, it touches and returns. So I'm not sure exactly what this graph would look like, but what we can assume is this. At 1 and at 3, okay, we have two zeros right here. We know they're going to touch here, touch or go through. In this graph, we know at 1, since it has a multiplicity that is odd, okay, odd multiplicity, since it's 1, the graph is going to go through that 0. However, at 3, since the multiplicity is even, it is going to touch and return. It's not going to go through. It will touch and return. Now, think about it this way. At -3, at this spot, it goes through. So what type of multiplicity would it be? Well, it would be odd. Same thing at 3. It goes through, so it will be odd. It goes through 5, so the multiplicity of 5 would be odd. Therefore, multiplicity at each of these zeros would be odd. I tried to do this one. This might be a better one, just in case. Let's say we have right here. Let's say we start here, come down, touch, and go through. We would have two zeros, right? We'd have it at -2 and 2. Now, the multiplicity at -2 would be even. Why? Yell it out in your living room, because it touches and returns. But why would the multiplicity at 2 be odd? Well, because it goes exactly straight through. So as we come back to the one that we were talking about here in this instance, and we'll come back to this right here, we notice that in this problem, that since it goes upwards and through, that the multiplicity would be odd, okay? And we already did I think we did, is this the only one? Is that the only one we need? All right, see, oh, they want us another one. The largest 0 would be 5, okay? All right, we're good there. And the multiplicity, since it goes through, would be odd, okay? And is that it? Oh, they want more. What is the value of the other one? And this would be 3, okay? And the multiplicity would be odd because it goes through at that 0. Again, look right here. It goes through, and through, so it would be odd. If it touches and returns, it would end up being even, okay? I'm hoping that will help you there. For those of you who are watching, these are great questions and ones that we just need to go through. All right, I think is there another one there? I see another one. I saw another one. If you've got another question, throw it out there. I'm looking at it right now. In fact, Travis, I think that was the exact one that you had there. But again, just kind of one as you look at it, we'll go forward. Oh, hold up. Did I not complete it? Oh, write an equation expressed as the product of factors of a polynomial that the graph might represent. Ooh, Use a lead coefficient of 1 or -1 to make the degree of f as small as possible. Yeah, this one's a little bit tougher, isn't it? And I can actually do this one for you since you're on here, and we could do that together. Oh, the other 0, are you good now? Can you hear me? If you can, just kind of let me know. It froze on you. I just want to make sure you're good. Can you still hear me? Oh, yes. The one after the answer was 5. If you're looking at, let me get this here. Let me make sure. I'm hoping that if it starts freezing up again, let me know. But this one was 5. This one was -3, and the next one would be +3 is what we would have there. Okay. So if I were to rewrite this, just so you're aware of this, it should look like this. It should be 3 of them, right? Perfect. If I could have 3 of these here, since this is -3, I will have an x plus 3. Since this one's +3, this will be x minus 3. And since this is a 5, we'll have that as an x minus 5. Okay. So basically what this is like I'm trying to write it what we call standard form is what we're looking for. So we're going to put these together, and really this is our equation. Okay. So if I were to multiply x plus 3 and x minus 3, I would get x squared minus 9. Okay, because I would distribute. Now, again, remember that when I would distribute, because this is a plus or minus, that's why I don't have, because you'd have a plus 3x and a minus 3x, which would cancel out, giving me just x squared minus 9. So now we take x squared minus 9 times x squared minus 9 times x minus 5. Sorry about that. Distribute to get x to the third. X squared times -5 is -5x squared. -9 times x is -9x. And -9 times -5 is +45. So as you put in the equation, you'd actually put in x to the third minus 5x squared minus 9x plus 45, and that right there should be your answer. And so again, I'm going to make sure, just in case, again, this one was one that was a little different. The reason why I put those 3 there was because, remember, we're thinking backwards. This would be at -3, +3, +5. And that's why that would be the case. And so when you think of when you put in factored form, just like we normally do when we find the zeros, we flip-flop the sign. Same holds true here. So again, I'm going to rewrite this on this one. It's going to be x to the third. Okay, x to the third. Rewrite this minus 5x. I'm hoping this is right. You ever, as a teacher, you always hope that that you're right on, especially on a podcast that's live. You know what I mean? All right, let's see. Ooh, it's not. It says it's equal to the correct answer, but it is not in the correct form. Read the instructions. Oh, they want us a product of factors. So what I actually did was I took it a step too far, okay? So let me make sure. I'm going to read this first. Before I do that, we're actually we don't even have to put all that, which is kind of nice. You actually just have to put in x plus 3, and that's the big thing. Coach needs to read the instructions. X minus 3 and x minus 5. So that's what we call product of factors, or you say a product of linear factors a lot of times. And when we do that, that's exactly what they're looking for moving forward, and kind of going from there, okay? The y-intercept, as we look at this, I mean, we could kind of identify with this one. It says use the equation from part B to find the y-intercept. Okay, so right here, actually the y-axis is not in the same like form here. So remember, and this is a tough one. I'll be honest. In fact, what I'll do is I'll give credit probably on this one for part of them. The top ones we should be okay on. Really, the bottom part is really the one that's tough. Remember the equation that I had gotten where it was like x to the third minus 5x squared minus 9x plus 45? What you could do is plug 0 in for x. So that means anything with x, you basically eliminate, leaving us just with 45 as our answer. So plug 0 in for x to get the y-intercept. So we get 45. So we know the y-intercept of the graph. And I'm trying to see, do they just want 45? Let's see if that's what they want there. Yeah, that's all they were looking for. So that's what we were wanting moving forward on that last one. All right, let me check out the questions here because there were some good ones. Perfect. The other 0 was 1. Yes, it would be solved the same way. So, in fact, actually, T. Ramos, I think what on that one, at least the one you gave me was the exact one that I did, but you might have gotten the secondary one. And if so, yes, you're correct. You would do it the same exact way that we just went through on that. I'll probably give some points for that at the end because that one was a little bit tricky. And I understand that could be a little bit tough there going forward, okay? So if you have any other questions as people start answering or texting me back there, feel free if you have any other questions, throw those out there and we'll take a look at them and go from there, okay? On this one, perfect. Sounds good. I just got that confirmation. On this one, and by the way, T. Ramos, you're the only one on here, so throw me any questions you need on this. On this one right here, we could use common denominators. Remember, x squared minus 16 would be x plus 4 and x minus 4. Since I have the equal sign, what I can do is say what's missing, to where literally I could multiply by x plus 4, x minus 4 by this one, and this one, all three of them. What they have on top and bottom, we could cancel. And what they don't, we multiply with the value up on top. For instance, this has x minus 4, but it doesn't have x plus 4. Therefore, we have to multiply the top by x plus 4. So that -3 must be distributed to the x and the plus 4. On the 4 over here on the top left, this one's missing the x minus 4 on the bottom. So you're going to have to multiply that by x minus 4. Whereas the one on the far right, you actually don't have to multiply by anything because both would cancel out with the x plus 4, x minus 4. We're able to do that because of the equal sign. It allows us to say, hey, if we do anything to one side, we can also do it to the other as long as it's to both parts. Remember that. Make sure it's to both parts there, okay? On this one's a little bit tricky. This is one where we're going to multiply by q plus h on both sides, okay? Q plus h by both sides. Let me do this, in fact, as I'm looking at it. That may be one that I go through. Let's do this. Let's go. I'm going to come back to that. This is one where we're going to multiply by q plus h on both sides. And in fact, I'll do that one in just a second. Okay, do that one in just a second. We'll come back to it. On this one, just remember that negative distributes to both. Okay, distributes to both there. Be sure that when you solve for it, if you divide by a negative, you flip that sign. So again, just be careful on that one. That one can be a tricky one. So just be careful on that. All right, let's see here. Okay, I went through all those. On this one, the big thing on this one is you could be kind of tricked out on this one because a lot of people will say, oh, my lead coefficient is to the third, and my lead coefficient would be 1, and my highest degree would be 3. You'd be partially right. The lead coefficient is 1 because as I multiply this across, this would only be 1, and really you don't need to multiply it. That's not what you need to do. But you do need to know if I did multiply it, what would be the highest exponent for x? Well, if this is x to the third, and this would have something with x squared, and this would be x, that means you have x to the third, x squared, and x. So when I list all of those out, x to the third, x squared, and x, this would actually be x to the sixth. So remember that if it's x to the sixth is the highest, or the highest degree is to the sixth power, therefore we'll have an even degree. I know it says 3 here, but you got to make sure that it's in standard form. Let me see if there is one in standard form. Oh, right here. It's perfect. This one's in standard form, so you don't have to worry about it. Because again, the 4 in this case is even. There's no distributing needed, so we know that the degree on this one would be even here. The lead coefficient would be negative. You can look on your rules on that podcast that I posted, but with an even exponent, with a negative lead coefficient, what we know is that it will both rise and fall to the, it will both fall to the left and to the right because it's negative. So it'd be like a parabola that goes like this, downward, okay? Because again, our rules state even degree with a negative lead coefficient, it will go downward, okay? Check out those podcasts. Those will help you out. Again, coming back to the other one, this one is an even degree, or even exponent, same thing. Okay, the highest degree is even. And we know that the lead coefficient's positive. So in this case, actually, it will go upward. It's like a parabola going upward, okay? Might not be a parabola, could be. But the big thing is we know it's going upward. So my end behavior is rise to the left and then also rise to the right, okay? So again, if you do that, make sure. So it should say it rises to the left and to the right. We should be good there, and we are, okay? Now, if they say find the x-intercepts on this, the big thing you want to do is you want to see where it crosses the x-axis. Well, this would be 0, 2, and -5 because you set all of those equal to 0. On this one, let me see here. Go over this one. Remember, this will fall to the left and right. Okay, so we'll hit that. Perfect. This one will also say find the x-intercept. So this is where you want to factor. So you want to take out that x squared, really negative x squared, which will change it to inside x squared minus 25, and then you could factor out on the inside. Find those x-intercepts and roll from there, okay? All right, perfect. All right, now on this one, again, if we're finding the zeros of the polynomial, okay, and again, the multiplicity, that's another big thing. Man, I messed up. I forgot to say that on the podcast. But again, we can do this here. Multiplicity, we'll look at this one in a second as well, okay? So we'll keep going through that. This one right here, value of the zeros, there'd be nothing here because remember, we're setting them equal to 0. This would be 4, and this would be 7. So, so which one has a smaller multiplicity? Well, this one is to the first multiplicity of 1. It's only one exponent. This one is to the second. So this is a multiplicity of actually 2. So this should be the smaller multiplicity is 4. Okay, get that one down. And let's see if it gets that next one there. And what is the multiplicity of that of the 0? That would be only 1. Okay, be only 1. And as we look at it, remember the odd multiplicity means it crosses the x-axis. Odd multiplicity means it crosses the x-axis. The other 0 would be 7. Okay, perfect. And multiplicity of that would be 2. We got that. Okay. And when it is an even multiplicity, remember it touches and returns. Okay, touches and turns around. Just a heads up there, touches and turns around on that. Okay, we'll come back to that one in a second. Want to make sure I hit on all of these ones here. I know that I went through there. Okay, perfect. This one has an even multiplicity with a positive. So even and positive, look on your rules, see what that does. Okay, we've already gone through that one there. Same thing for that one. Okay. Is this a polynomial? Remember, it's got to be continuous, okay? It's not continuous, so we're going to say nada. Okay, if it has a break in the gap, we're going to say no on that one, okay? So again, that's kind of what we're looking at there. I know that I gave a lot of information regarding some of these problems, and maybe you're not perfect, and that's okay. But I'm going to go over 2 of the tougher ones, and then we're going to call it a night so I can get back to my beautiful daughter, my beautiful wife, okay? All right, so this is A. Just want to make sure this is A. This one's Q. This is Q. And it said solve for Q, okay? All right, and then we'll go to the bottom one where we'll give the x-intercepts and then also the multiplicity on those, okay? All right, so first thing we want to do is, we could do a couple things, but one of the things I like to do is get rid of this Q plus H, okay? So we're going to multiply it. I don't like fractions, so we're going to multiply that out. It's like fractions. I hate fractions. All right. So we're going to take A, and we're going to distribute this out to where we have now AQ plus AH equals QH. Now, since we want Q's together, and again, just so we're clear, these are the 2 Q's. Let's subtract this AQ so that it's on both sides, okay? Now, why do I want to do that? Well, because I want to get Q by itself. And now since there's 2 of them, I could factor out, kind of like what we're going to do down below, to where when I take a Q out, I'm left with H minus A, because now I've got the Q's out of there. So now if I've got Q times H minus A, I divide by H minus A to cancel, to where now I get AH all over H minus A equals Q, since I have Q by itself, okay? So that's kind of the strategy. Get that, if I get multiple Q's, get them on one side. Once I get those fractions out of there, and then I can factor out a q and divide if I need to on that problem. Okay? All right, last one. On this one, we're trying to find what the x-intercepts are. So we got to factor, okay? All right, so what can we bring out to the outside? What's in common? So you think of Brad Pitt, you think of Coach Johnson, right? You think of tall, you think Coach Johnson. So it's something that's in common, if that makes sense, okay? Something that's in common. So what's in common with this problem? Well, the thing we could pull out is an x. So what's left over? Well, we'd have now an x squared minus 10x plus 25, okay? And that equals y, or f of x, you could say. So can we factor out further? You sure can. Two numbers when multiplied get me to 25, but what did I get me negative 10? Let's say x minus 5 and x minus 5. I think that will work. So my question is what are the zeros of this polynomial? Well, we know that we have, if we set all of these equal to 0 and solve, we get x equals 0, x minus 5 equals 0, and there's actually another one. So we would have x equals 0 and add 5, x equals 5. And there's also two of these, okay? So actually, if you have multiple of them, that's where multiplicity comes into effect, where the multiplicity of this would be 1, because I've only got 1, right? Now, if this was x squared, which it's not, but if it was, then that's when it would have a multiplicity of 2. But because it's only 1, and we can list that there. So my multiplicity of 0 would be 1. The multiplicity of the x-intercept of 5 would be 2. So what happens is this, is we don't know what exactly the graph looks like, but at 0 and 5, 0, we know we're going to go through it. Why? Because we have an odd multiplicity. And at 5, we're going to touch and return. Why is that? Well, because it is an even multiplicity. So we can assume that at those graphs that we have, if it's even, touches and returns at that 0. And if it's odd, it goes straight through. All right. I hope that was helpful for y'all. I tried to make sure that I went through a lot of those problems on the MML. The big thing, stay up to date with all that's going on, okay? You don't want to wait till I come back next Monday. That's not to say that I won't have grace on answering questions, but at the same time, I know MML is due by tomorrow. Make sure that you finish that class and then move on to the next section, which should be the I believe it's 2.4, okay? Check me on that, but I believe it's 2.4. So make sure you keep going, keep progressing, like I know you will, and keep moving forward, all right? Thank you all so much. Appreciate y'all, and have a great day. Oh, yeah, by the way, just to sign out, I thought you would appreciate this. Some of you will appreciate this here. I'm not sure which ones I have or have not shown. Let's see. Oh, yeah, I'm going to show this one. Let's do this one. So I'm teaching Emmy how to put up the field goal post, okay? So this is kind of what I've been teaching her. See if we got, there we go. Oh, there we go. Isn't she so sweet? I love that little pumpkin. Again, thank you all so much for all your help there. Keep working. Keep it up. See y'all. Bye.